In this video, we're going to look at using midpoint and Simpson's rules to approximate an integral, and then compare the approximation to the actual values of the integrals. So, we're looking at the integral from 0 to pi of x cosine x dx. We're going to use 4 subintervals to approximate this integral with the midpoint rule first, and then with Simpson's rule. And then we're going to compare the answers we get with the actual values of the integral. Well, first, let's go ahead and just calculate that actual value. So we've got x cosine x that we're trying to integrate, so we can do that by parts. We'll let u be x and dv be cosine x dx. Then du is dx and v is sine x. So we apply our integration by parts formula. U times v is x sine x. V du is just sine x, so we get x sine x minus the integral of sine x dx, and both of these will be evaluated from 0 to pi. That first piece, the x sine x, when you put in 0 or put in pi, you get 0 for both of those values. Antiderivative for sine is a negative cosine, so we'll get a positive cosine due to that minus sign in front. Evaluate that from 0 to pi, and we get negative 2. All right, so the actual value of this particular integral is negative 2. So we're going to compare this negative 2, the actual value, with the approximations that we get from midpoint and Simpson's rules. So we're told that we have 4 subintervals that we want to use. Our interval is going from 0 to pi. So first calculate our delta x. We get pi over 4. The midpoints of our 4 subintervals, well, from 0 to pi over 4, we get pi over 8 as a midpoint. Pi over 4 to pi over 2. 3 pi over 8 is the midpoint. And so on. The other two midpoints are 5 pi over 8 and 7 pi over 8. We calculate the function values. Those 4 function values, add them together, and multiply by delta x. That's what we get for the midpoint rule. If we put that stuff in a calculator, we'll get approximately negative 1.946-ish. So the error in that approximation is we'll take the actual value and subtract off the approximation, and get the error as actually negative 0.054256. For Simpson's rule, remember the formula is delta x over 3, so we'll get a third of pi over 4. And then we do the function value at the left endpoint, 4 times the function value at the right endpoint of the first subinterval, 2 times the function value at the right endpoint of the second subinterval, and so on. Remember the coefficients in the middle alternate 4, 2, 4. And then finally, the last one is the function value at the right endpoint. Put all that into the calculator, we get about negative 1.986-ish. And so we can calculate the error there and get about the error is about negative 0.014.